Yes, sir.
So today we will discuss about method of joint, what is method of joint and what are the different steps that you have to follow for method of joint. Fine. And you have to use those steps only for solving the numericals. So let me start with the method of joint and then steps, and then I will explain it with a very simple example. Let me share the screen. Screen is visible now?
Yes, sir.
Yes, sir, it
Yes,
is
sir.
visible.
Okay. Now we are going to discuss method of joint. So first write down some important terms, one important definition, and the what are different steps you have to follow. Then I will explain the steps. So first write what is method of joint. This method is used. This method calculate. This method is used to calculate forces in the number of members of the truss, to calculate the forces in the number of members of the truss, comma, when a system of concurrent forces is found, when a system of concurrent forces is found at the joints, full stop. So due to the concurrent system of forces, due to the concurrent system of forces, two independent equation of equilibrium can be formed.
Sir, can you repeat due to the?
Due to concurrent system of forces, two independent equation of equilibrium can be formed. Two independent equation of equilibrium can be formed at the joint. At the joint. Okay. Then write steps involved in analysis of method of joint. Now I am writing here steps involved in analysis of method of joint. Analysis of method of joint. So there are four steps. Write down step number 1. Find the equation of, find the reactions. Find the reactions at the support of the truss. Find the reactions at the support of the truss, considering the entire truss as rigid body.
So please repeat.
Okay, I am repeating. Find the reactions at the support of the truss, considering the entire truss as rigid body. Considering the entire truss as rigid body, and then applying equation of statics.
Sir, please repeat.
Okay, should I write it here for your convenience on the board?
Yes, sir.
So I am writing here, find the reactions at the support of truss, considering the Entire truss has rigid body. And then applying equation of statics. Okay, this is step number 1. Now write down step number 2. Select a joint where only two members meet and draw ABD of the joint, assuming the forces in the member to be compressive. So I am writing it also along with dictation so that you can check if you lose any step or any point. So this is step number 2. Next is step number 3. Apply equation of statics for the joint and find the forces in the member meeting at the joint if the value of the force is positive. This is an important step, okay? If the value of the force is positive, then it is under compression. Otherwise, it is under
Tension.
tension, okay? So this is the step number 3. Now the last step, select another joint where only two member forces are to be found and repeat step 2nd and step 3rd until the forces in all the members are determined. Okay.
Repeat कर दो sir. Repeat कर
See
दो
it,
last line.
see it on the board. I have written it. So have you written all these steps?
Sir, just a second.
I have also made it on the board so that you can cross check if any line is missing or any word is missing, because these 4 points are very, very important points for you to remember. So once you write, then tell me. I will explain all the 4 steps and then I will take an example. So it's completed from your end.
Yes, sir. Sir, 1 minute.
Okay.
Done, sir. Thank you.
Okay. So you can see the steps here. What are the steps which are included in method of joint? The step number one is find the reactions at the support of the truss, considering the entire truss as a rigid body, and then applying the equation of statics. Means first step is the same step that we do in the case of beams. Means as I have told you in the previous class that we have a simply supported perfect truss will be there. So for that simply supported perfect truss, first we have to see which type support is that, hinge support or roller support. Accordingly, we will make the video of the support, and then we will calculate the support reactions for the particular truss. So this is the first step that you have to do. Step number one is clear now. We have to find only the reactions at the support. Is it clear?
Yes, sir.
Students, step number one is clear. Now come to step number two. Step number two says that select a joint where only two members are meeting. Means if you have a number of triangular truss are there, means there are number of members, then you have to select that particular joint where only two member forces are meeting. You don't go for three members or four members earlier. Fine. So after calculating the reaction that is support, then we will go to the joint and we will take that particular joint where only two member forces are there. So select that particular joint, and after selecting joint, you see here, draw the ABD of the joint. We have selected the joint where only two member forces are there. Then we will draw the ABD of that particular joint, and assuming the forces in the member to be compressive. This means that we will assume that direction towards the joint, we will take the direction towards the joint. Let me explain it, the example. First read all the step, then I will explain it with the example. So step two, we take the joint where only two member forces are there, then we make the ABD of the joint, and after making ABD, we will assume the forces in the members are compressive, means towards the joint we have to take the direction. We will not take the direction away from the joint. Fine. Now comes to step number three. Step number three says that then apply the equation of statics for the joint. Then we will apply the equation of statics and find the forces in the member meeting at the joint. Okay. Then we will find the forces in the member with the help of equation of statics. Now the important point here, if the value of the force is positive, see here, if the value of the force is positive, then it's under compression, means we have to write C, and if the body, if otherwise if it is in tension, we have to write T. That means if it is positive, we will assume it to be compressive C, and if it is tension, that means if it is negative, then we have to write the direction as T, tensile. So this is the step number three. Now the step number four, select another joint where only two member forces are to be found, and repeat the step number two and step number three until the forces in all the members are determined. So basically step number two and step number three are the more important steps. So I have explained all these steps. Now I will just give you an example for how these steps can be applied in a method of joint. Yes.
सर जो स्टेप्स आपने बताया उसमें क्या है कि दो जहाँ पे फोर्सेस मीट गए हैं तो फिर तो सिंपल ट्रायंगल के लिए ही केवल अप्लाई होगा क्योंकि अगर स्ट्रक्चर बनाएंगे तो उसमें मिनिमम 3
Yes.
लगेंगे.
No, like that you can see minimum, what we are saying, minimum two forces here. If I make the diagram like that, here you can
यस
see.
सर वही मैं कह रहा हूँ केवल ट्रायंगल के लिए होगा ना ये तो.
Yes, yes, this can be applied to this also. This is here. Okay.
लेकिन सर फिर
Now you
3
can
मेंबर फोर्सेस आ गई एक पॉइंट पे.
listen to me what I am saying, beta. You just listen first. See, there are different points here. Okay.
Yes sir.
Let us say different points. Now, if we go for the point A, at the point A, how many members are there? 2. At the point B, how many members are there? 1, 2, 3. At the D point, how many members are there? 1, 2, 3, 4. And point C, how many members are there? 3. At E point, how
Three.
many members are there? 2. 2. So according to my step number 2, we have to select a joint where only 2 members meet. Either we can take joint number A first, and either we can take joint number E first. Okay. So what is method of joint? Method of joint says that we have to select the every joint and we have to calculate the forces in all the members. This is the method of joint. So for selecting the joint means which joint we have to take first. We have to decide earlier. So we will first see how many members are meeting at a particular joint. Accordingly, we will take the joint first. So let me clear it first, because this is a little typical case. I will first tell you the simple one. See, for this case, let us say this is 6 kilonewton, okay, and let us say this angle is 30 degree and this angle is 60 degree, and this is vertical here. Let us say 60 degree, and this distance we can say that, let us say it is 6 meter, or let us assume that this is equal, because we are just explaining it. So you can see from here, if I draw the perpendicular from here for this force bit might comes here. So this, what was the perpendicular distance of this force from the point C is 3 meter. So what is step number 1? Step number says that calculate the reactions at support. Fine. For truss, first you have to see what are different reactions at the support. This is the hinge support and this is the roller support. So we can make a diagram like that. So I am just making it here. So this is VD and this is VB, sorry, VA, and this is HA. Angle is 60 degree. So this is the step number 1. What I have told you, I have just made the ABD here. After that, apply the equation of statics. Next, I will apply the equation of statics, summation Fx, summation Fy, and moment Ma is equal to 0. So in HA, there is no other force. HA will be equal to 0. So this will be question number 1. For VA, how many forces are there? VA plus VD is equal to how much? 6 kilonewton. And what is moment equation from here? HA into 0 plus VA into 0, then minus 6 into 3, and plus VD into what is the direction of this force? Or you can say the perpendicular distance. What is the perpendicular distance of VD? Can anybody tell? 6. Okay. So 6 VD should be equal to how much? 18. Then VD will be equal to how much? 3 kilonewton. Okay. So when VD is 3, so similarly VA will also be 3. So we have calculated VA is 3 kilonewton and VD is
Sir, please show the
similarly.
previous slide.
Just wait. Should I write first of all? Then I will show it. This is VA and this is VD. Okay. So now what is the step number 2? This is step number 1. What is step number 2? Now we have to select any joint. So if we can see here, we have point A here. Okay. We have point D here and we have point B here. We can take any joint as per our convenience, because here we have 2 members. At the point D, we have also 2 members. Okay. At point B, we have also 2 members. But we will select only those members first which are parallel to the horizontal axis. That means either we can take A first or either we can take D first. If you take B, you can see this. You have to resolve these two forces. This also you have to resolve. This also you have to resolve. So first we will take the joint A. So should I proceed to next slide now? I will written it.
Yes, sir.
Okay, now step number 2. Let us go to step number 2. Step number 2 says that we have to select a joint where only two members are meeting. So we will take joint, taking joint A, taking joint A. So after taking joint, what we have to do? We have to make the ABD of the joint. So see, I have made the ABD like that. This is the ABD of the joint. This is VA. Angle is how much? 60 degree. This is point A. And after that, I have told you that see this. Select a joint where only two members are meeting and draw the ABD of the joint, assuming the forces in the member to be compressive. Means we have to select that these forces must be compressive. This will be, let us say this is FAD, and let us say this is FAB. Okay, this is how make the ABD. Then after that, what we will do? We will resolve it like that. This is VA. FB sin 60, and this is in fact it is FAB sin 60 and it is FAB cos 60, and one force is which one? FAD. Now apply equation of statics. Fx is equal to 0, Fy is equal to 0. From these two equations, we will get the value of FAB and FAD. Please tell me what is the value you are getting? This is equation number 1. And for vertical force, what will be there? This is equation number 2. So from these two equations, tell me the value what you are getting for FAB and FAD.
Sir, FAB is 3.46.
What is the direction? Positive or negative?
Positive.
FAB is positive.
Yes,
Yes, sir,
sir.
positive.
Positive means what I have told you. If it is positive, then we have to take the sign as compressive. What is FAD?
Minus 1.73.
So this is tensile. Okay. So we have calculated these two values. Now see, our assumption is that we will take the direction towards the joint compressive. That means we are assuming that direction is towards the joint is compressive. It is positive. That means it is compressive. It is not positive. That is direction is tensile. So now we have taken the joint A and calculated the value FAB and FAD. So see here. So we have calculated FAB. This one we have calculated, and FAD we have calculated. Okay. So now which joint we will take now? Second. Now we will take joint D. Now taking joint D. Once we will take joint D, what will be the diagram now? Like that. Okay, this is VD, and we have calculated FAD and FAB. This is FBD, and this is FAD. Angle is how much? 60 degree. Okay, so this is the ABD of the joint D. Now again you apply the equation of statics.
थ्री फोर्सेस एंड लैमीज भी अप्लाई कर सकते हैं.
No, you can apply, but here you apply only the resolution of force. That will not create any panic. Okay, there might be
Okay.
condition that you find any difficulty. So to avoid the confusion, don't apply Lami's in trust questions.
ओके सर.
So what is the value? Can you anybody tell me what is value of FBD? What you are getting? Because FBD we have already calculated.
FBD is equal to 3.464.
Direction?
So positive.
Negative.
Compressive.
नेगेटिव है सर
Negative है सर.
Tensile.
टेंशन
Okay. So this problem is clear to you. Should I explain it once again? See,
Yes,
one
sir.
point you
Please
have
explain once again.
see one point you have not asked me. That's why I was waiting that why you have not asked. See, at the joint B, joint A, B, I have taken all the directions towards the joint. See, FAB and FAD you can see, and then I have solved it. So nobody has asked me why I have taken the direction of FAD outward, why not inward. Reason behind that,
The
because
tension में है.
yes, tensile, because our assumption is that we will assume the direction towards the compressive, but we are getting direction reverse. We are getting tension. That's why we have taken the direction outward. So when you are putting the value here in the fx, you have to write the plus sign, not the negative sign. Okay, according to this. So please don't make this mistake here. Otherwise, your answer will not be correct. So here you have to make the FBD once again.
Sir, we have to take all the points.
Yes. No. You have to take only those points. After that, if all the members are calculated, then you did not to go for other points. See, in this case, we have taken point joint A and joint D. So there is no point for us to go to point B because we have calculated all the force members. So this is your FBD sin 60, and this is your FBD of 60, and this is your FAD. Fine. So after that, you get the value FBD as 3.46 kilonewton tensile. So everybody is getting these three values.
सर FBD पॉजिटिव आ रही है.
Yes sir, positive आई है, negative नहीं आई है.
Means you are saying that FBD is 3.46 kilonewton compressive.
Yes sir.
Okay. So I think the steps of making the or using the method of joint is clear to you.
Yes sir, clear.
So please make a note
yes
of this
sir clear
in your register and try to do some problems at your home from the book, and uh, we will certainly do some more problems tomorrow. Okay, we will certainly do some more problems tomorrow. Okay, so make a note. Have you noted down this problem? This is the problem. This problem is the base problem for you. Please make a note of it. I will start it from the beginning. I am starting from the this starting of the problem. First slide you have made in your register.
Yes sir.
Now the second slide. Second slide is completed.
Yes sir.
The third one you can also make. So in the end you have to make a table. I forget to tell you table. So you have to make the table in the end, and table should be like that. Table should be like that. So this table also comprises some marks. So don't forget to make this table.
सर ये वाले टेबल में फाइनल आंसर के बाद बनानी है ना सर.
Ah yes, after calculating all the values.
Okay, sir.
So this will be your FA. This is serial number 1, serial number 2. Because this is a very simple problem. Only we have three members. When we discuss some big problem, so in that case 7 or 8 members will be there. So here it will be AB, then AD, and here it is BD. And you can see force magnitude FAB is 3.46, and here it is how much? Same FAD is 1.73 and it is 3.46, and this nature is compressive. Here it is tensile, and here it is tensile. Okay, so this is the how you have to make the table, and this table also comprises half marks. So you have to make that table also.
Please show previous slide once.
So I hope you have written this. So just make a note of this in your register and make the base. So we will solve some more problems on Wednesday.
Okay, sir.
And should I unshare the screen now?
Yes, sir.
Okay. So now the attendance. Jashandeep,
Present, sir.
Rama,
Present, sir.
Divyam,
Present, sir.
Mohit,
Present, sir.
Shekhar,
Present, sir.
Sahil,
Present, sir.
Vanshika,
Present, sir.
Vidhi,
Present, sir.
Shivansh,
Present, sir.
Hiren,
Present, sir.
Samir,
Present, sir.
Sudiksha,
Present, sir.
Yash,
Present, sir.
Vanshveer,
Present, sir.
Neha Goyal,
Sir, you skip my name.
sorry, Sankirat,
Present, sir.
then Neha Goyal,
Present, sir.
Parth,
Present, sir.
Aditya Rajput,
Present, sir.
and Satvik.
Present, sir.
Aditya,
Present, sir.
Rajwal,
Present, sir. Present.
Shantanu,
Present, sir.
Naman,
Present, sir.
Yuvraj,
Present, sir.
then Nikita,
Present, sir.
Pragati. So any information about Pragati? Then Arunit,
Present, sir.
Hemang,
Present, sir.
then Anand,
Present, sir.
then Rakshit,
Present, sir.
Aryan,
Present, sir.
Nibir,
Present, sir.
Path Bansal,
Sir, Parth Bansal present.
and then last is Bhavi Singh.
Present, sir.
Okay, beta. So that's all from my side. So we can meet on Wednesday. Okay.
Okay, sir.